I like to think of gravity as the invisible glue of the universe. It is what holds Earth, the Sun, and all other objects into place. It is what makes me stay put in the ground right now instead of floating out into space. So, since gravity is a force inherently present in our lives, we should try to understand its history, laws, phenomena, and theories a little bit more deeply. Isaac Newton searched for the reason why heavenly bodies move the way they do. He reasoned that the force between Earth and an apple is the same force that pulls all other bodies in the universe, combining these laws into the Newtonian synthesis. This leads us to the law of universal gravitation. Something attracts something else with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers of masses. Well, all you need to take away from this is that the greater the masses, the greater the force of attraction between the objects, and the greater the distance of separation, the weaker the force of attraction. On the same note, gravity gets weaker by the inverse square law. The greater the distance from Earth's center, the less the gravitational force of an object, making its weight, not mass, get smaller. Additionally, there is still a gravitational attraction between any two masses, no matter how far apart they are. Do you know how in some science museums there are scales that show what your weight would be like on each planet? In fact, your weight can change on Earth itself. For instance, if you stand on a scale on an elevator going up, the floor pushes harder against your feet, causing an increase in your weight. During a free fall, for example, the support force is zero, as well as the weight. This results in weightlessness, the condition in which an object experiences no support force and exerts no force on a scale. Weight, on the other hand, is the force that an object exerts on a supporting surface, which is often due to the force of gravity. But gravity also influences other aspects of our daily lives, such as tides. There are typically two high tides and two low tides each day, because gravitational force is stronger on the side of the Earth closer to the Moon, and vice versa. But this interaction between Earth and Moon is action at a distance, as each pulls on each other. Although they are not in physical contact, the Moon is interacting with Earth's gravitational field. Any object near Earth will be accelerated in the direction of the field line at that location. So, if a poor alien ship is pulled by Earth's gravity, it is interacting with its gravitational field. Gravitational fields relate to Einstein's general theory of relativity, and black holes and wormholes also have everything to do with gravity, but we'll have to leave them for another video. Going back to our Earth, have you ever wondered why it is round? Exactly, it's because of gravity. Everything attracts everything else, and so Earth has attracted itself together as far as it can, according to the law of universal gravitation. Many more concepts that go beyond Newton's initial perceptions are being created and questioned every day. The universe is infinite, and because of gravity, everything can be thought of as being interconnected. The tides, our weight, black holes, and so much more inherently experience independent of the force of gravity.